Hello, so welcome to episode 3. In this episode, I'll be talking about the additive process chain of 3D printing. So I want to start episode 3 with a misconception. So the misconception in this episode would be, is 3D printing a plug and play technology? Can anyone just buy a 3D printer and 3D print something for him or herself? So in my opinion, it should be a yes and no answer. Yes, if you're just simply printing a part that you found off the internet and you do not want to further customize it or further improve it. And no, it is not a plug and play technology if you're actually designing a part from the ground up. There's actually a lot of work that goes into 3D printing a part that you want. So now let us look at what the 3D printing cycle is like. Next. So now you can see the simplified additive manufacturing process cycle that I have shown on the slide. It comprises of 7 steps. So firstly is the conceptualization of your idea and actually modeling out in 3D. Second step is the conversion of this 3D model into something that the 3D printer can read. Next is the preparation of the machine. Fourth is the building of the part. Fifth is actually the cleaning up of the support materials that you use during the building process. At 6 is the post-processing, so to make your part looks a bit nicer. And 7 is the final object that you have. So steps 1 and 2 can be skipped if you simply just download a 3D model from the web. So then you can straight away print, and then it becomes more of a plug and play kind of a technology. So yeah, next. So the first step of the 3D printing process is the conceptualization of your idea and actually 3D modeling your part. So this is actually the most tedious and time consuming and the most skilled step in this 3D printing process. So what is a CAD file? CAD stands for Computer Aided Design. It is a 3D model of a part that fully describes its external geometry. So basically it tells the computer what your part that you want, what's the size, what's the dimensions. So you can obtain a CAD file either by one of the 3 steps using a CAD modeling software, downloading CAD model from the internet, or 3D scanning an object. So this I'll be explaining in the next 3 slides. It's also important to know that there are design for additive manufacturing rules when you are 3D modeling your part. So if you know certain limitations of the process that you're going to use, the better you can design it on the 3D in the 3D model, then it's easier to print afterwards. So this is quite important to know. So next we have CAD modeling. So I want to show 2 types of CAD modeling in this slide. Firstly, there's a solid modeling kind. So an example of this would be Tinkercad, which you could download for free. So solid modeling means that you are modeling a 3D object by either adding or subtracting solids. So every time if you want a shape like the one you see on the screen, basically you first have to put a rectangular block and then you have to put a cylindrical block, and when you join these 2 together, you form the shape that you see on the screen on the left. Another type of CAD modeling is called surface modeling. So this is by a software called SketchUp. It is also free to download. So surface modeling, instead of solid modeling, what you do is that you first have to define a surface and you slowly build the 3D model surface by surface. So like you first build the flooring, then you build each individual wall, and then you build the roof of your house. So it's 2 different methods of 3D modeling. So yeah, next. So another method of getting a CAD file is simply by downloading the CAD file or downloading the STL file. So some places in which you can download the 3D models are thingiverse.com or myminifactory.com, or you could also, there are also service bureaus that have a model database in which you can pay some money to buy quality models from designer such as shapeways.com. So yeah. Next. So the last way of getting a 3D model in my presentation would be 3D scanning. So basically you could buy a 3D scanner such as the MakerBot digitizer. Basically, as seen in the picture, you could put your small toy trinket onto the platform, and this digitizer will 3D scan your object and form you the 3D model. So this 3D scanning has a variety of scales. So you could buy a small digitizer that can scan your toys, and there is also a large 3D scanning equipment that can actually scan your entire body. So these are the available 3D scanning methods which you could probably easily find. So next. So next step is the conversion and the repair of the STL. So after you have modeled your 3D model, you have to convert your 3D model file into the STL file format, which is the current standard for 3D printers. So this means that the 3D printers will read file type that is .stl. So, but though the conversion from the CAD model to an STL model could result in information loss. For example, if in the 3D model you draw a perfect circle, but when you convert it to an STL model, your circle might not be perfectly cylindrical, concentric. So, but that's probably not so much of an issue. However, if you design something with a complex shape, when you convert it to STL, there is a possibility that there are some inherent defect that results from this conversion. In that case, there are software that helps in the repair of such STL files, such as Magix or NetFab. So NetFab Basic is a free software in which you could purchase to help you repair on. It's a free software that you could download to repair your STL file. So on this slide, you can see what it would look like on a typical software that repairs STL file. So you can see that there are green color triangles on this gray part model. So basically these green triangles could be the repair that the repair software did for you to make sure that your STL file is free of any defects. So yeah. So the third step would be the slicing of the STL file. So once you have the STL file, you have to slice it to individual layer. So each 3D printing manufacturer often has their proprietary software that slices STL file and generate the G code that programs the 3D printer. So this slicing creates this .g code file, which would give the instructions to the 3D printer to move in the X, Y, and Z axis so that they can 3D print the part. So in slicing, it is very important to orientate your part well in the machine build space, because the orientation of your part would also have an effect on the mechanical properties of your part. And next, in the slicing process, it also generates support to support overhanging features that you might have. So yeah, let's see the next slide. So this slide shows you the build direction. So this slide, I want to say that the mechanical properties of 3D printer is usually weak along this build direction, which is the Z-axis. Why? Because of the layer by layer process. Each layer might not be totally melted or fused to the layer that is above it. So what this means is that there is a horizontal crack along that is possible to be found in between each layer. So this crack makes the part to fail in the build direction orientation more as compared to the X and Y axis. Another reason why you want to think about the build direction is that if you want to build something like this tensile coupon diagonally, then you will require a lot of support material. However, if you build this tensile coupon vertically or lying down, then you would have zero support material that you require. So yeah, next. So the next step, step 3, is machine preparation. So now that you have the required file to send into the 3D printer, you need to prepare the machine. So first you need to select suitable process parameter for the specific material. So usually each material has a specific process parameter, such as different melting point, probably different extrusion speed, and maybe the extrusion width, because each material can expand or contract differently and flow differently when heated up. So these process parameters have to be individual to each specific material and process. Next, you have prepared the build material for the print. So sometimes in 3D printing, you have to recycle the build material. So you have to make sure that you recycle the build material and you make sure that the build material is at optimum condition for 3D printing. So next we have prepared the print bed level or calibrate the power source. So in this, sometimes the print bed that you're 3D printing on, you have to make sure that it's flat, or also in the case of some electron beam method, you have to calibrate the electron beam, because each time you off and on the machine, the calibration might run. So yeah, next. So step 4 is the building process. To me, this is the easiest part of the 3D printing process, mainly because this step is fully automated and the machine goes about building each layer by layer on its own. So you can just leave it there for 1 or 2 days and it will probably finish building. So most printers have a similar sequence of steps as follow. So first is the deposition or spreading of material across the build plate. Next, there's a binding mechanism. So the printer can either be spraying glue onto a specific pattern, or probably using a laser to melt the specific layer. The next step, the printer would be lowering the z-axis height so that it lowers down, so that you can build the next layer on top of the layer that you just built. So on fourth, you have your layer that is formed. So in this building process, it's important to note that some processes have controlled environment, such as having a constant temperature environment. So this, what you'll see, this is in like ABS. People would say that it is better to have a controlled environment, a higher elevated temperature. Other controlled environment could be having like vacuum or inert gas environment. So this is more related to the metal printing. So why you have vacuum, so that hopefully with the vacuum you will reduce the porosity due to the oxygen in the process. So yeah, next step. So in this step, you can see the build process that I mentioned. First is the application of your material across the powder bed. Then is the binding mechanism. So you could either bind it using glue or you can laser. And then the third step will be the lowering of the build platform. And the fifth step, you have your layer. So and then you go back to the application of your build material across your build plate. So this picture is taken from VoxelJet. So VoxelJet is also a 3D printing company. So next slide. So one thing to know before I go on to this slide is that the pictures I use in this presentation are taken from websites of 3D printing company or 3D printing blog that I think it's quite commendable and quite respectable. So you could also go to the link below the image website to see what the company or that blog is talking about, and that could help further your understanding of 3D printing. So step 5 is the removal and cleanup of your support material. This to me is the most difficult part of 3D printing, but it is also probably the part in which companies make their money off from, because the removal and the cleaning of parts from the 3D printer is sort of like a company secret or process secret that one can develop and improve on to make sure that your process is like smoother as compared to other people. So in this step, what people normally do is that people have to remove the support material and people have to clean the machine in preparation for the next build. So yeah. So in the picture here, you can see what I had to clean up. I was printing some toy robot on my FDM printer. So I have to use a pen knife and some pliers to pluck away all the support material that I used during my printing of this robot. So yeah, next slide. So the next step will be post-processing. So once you've cleaned up the part, you could further apply additional coating or additional polishing to the part so that it becomes like metallic finish, or it becomes very shiny, or becomes very smooth. Because after you 3D print a part, the as-built surface is usually not very smooth. You can see the layer by layer pattern due to the 3D printing process. So this is also another step in which companies have many trade secrets on, and they don't usually tell you how do they make their part as smooth or as nice as you see on a trade show as compared to a part that you just get off a machine. So three types of post-processing methods are polishing, heat treatment, and surface coating. So yeah, so surface coating I think is quite an interesting aspect. So what this is that people has infused polymer with some kind of conductive material, and then because of this conductive material, you can actually coat the polymer with a metal coating using an normal coat and electrode coating method. So basically you just put the part into a solution and you put electricity current, and then the particles in the liquid will just stick onto your part because your part is like conductive. So I think this is quite an interesting post-processing method. So yeah, next. So step 7, you have the final object already. So now you can use the object to test the fit form function of it, and you can see whether people want to buy it or not. So on the final note, I want to say that different 3D printers could have additional steps that are not shown in this slide, but the steps I showed in this slide are basically very generic and very general across the board. So once again, I want to summarize the 7 generic steps. Basically, first is the conceptualization of your idea and actually 3D modeling out. This to me is the most difficult, so this is what you should be looking at. Next is the conversion and repair of STL. So currently this segment is done using software, so you don't really have to learn much. Then machine preparation, yes, you have to do a bit of work. And fourth, the building process is fully automated, so that's very good. You can just leave it to print on its own. Fifth step and sixth step is the support cleanup and the post-processing. So this is where it differentiates the normal person from an actual manufacturer that actually sells the part as an end-use part. So as usually an as-built 3D printed part is not really ready for commercial sales immediately. So people usually develop such post-processing skills such as like maybe spray painting their 3D parts so that it looks very nice. So the last step is that you have your final object. So hope you learned a bit from this episode. So yeah, next. So we come to the end of this episode. So the reference for this episode is the Additive Manufacturing Technologies book by Ian Gibson, David Rosen, and Brent Stucker. So basically they came out with this generic 7-step in which I use it as the model for this episode. So other information that I know about 3D printing is mainly taken from this master level 3D printing course which I took from the Nanyang Technological University. So yes, I hope you enjoy episode 3 and stay tuned for the next episode. Thank you.